Alrighty, this is going on page 88 when we are done. Today, we are going to look at equations of circles, right? We've looked at circles, lines that intersect circles, angles, all types of angles with circles. Today, we're going to look at circles on the coordinate plane and writing equations, okay? We are not solving for anything. I'm not finding an arc measure. I'm not finding an angle measure. I'm not finding lengths of things. And my goal is to get an equation. It's like the y equals mx plus b for circles, okay? So it's something that I could take and then go and graph on the coordinate plane. So the equation of a circle is based on the distance formula. Now, when we came up with the distance formula last semester, we saw that the distance formula comes from what? What do we derive that from? Or what is it similar to? No. What could I use instead of distance formula when I'm looking? I'm on the coordinate plane. I'm looking for the length, the distance between 2 points. What can I use to find the distance between 2 points besides the distance formula? Well, I know I can find the slope. I don't know how the slope's going to help me with the distance. The midpoint's not going to help me with the distance. It'll help me find the midpoint. No. Come on, y'all know this. Yeah, you do. Go draw yourself a little grid, put 2 points. Yes, you're the only class that hasn't been able to come up with this, if that's what you're asking me. Okay, so congratulations. Now, draw your little self a little x and y axis. Okay, think I got these 2 points, right? Okay, and I want the distance. Are you allowed to count diagonally? No. No, that gives me the slope. That didn't give me the length. What? Pythagorean theorem. Woohoo! Oh my gosh. Y'all about to make me cry. What?
You didn't say it was on a triangle.
No, I didn't say it was on a triangle. Does that look like a triangle to you?
How could you put Pythagorean theorem when it's not a triangle? Oh.
Like that.
You're smart.
No, that is not rise over run. That gives you the slope.
She's not telling me.
Ugh. Okay, just stop. Good Lord. All right. This comes from the Pythagorean theorem. And there's a reason you want to think that it comes from the Pythagorean theorem. Okay, we'll look at that in just a second. That's why I said you've got to know that those two are connected. Because if you don't remember the distance formula, you can totally make that into Pythagorean theorem. Finding the slope ain't going to get you nothing, but you could use Pythagorean theorem. All right, so we're going to use this idea to come up with the equation of a circle. Even though with the equation of a circle, I'm not looking for a length of any sort, it still is what I use to come up with that equation. So when I look at this circle, the green dotted line represents what? The radius. Okay, that's an R. The radius. This red point is the center of the circle. Okay, so we can label it C. But then there's an ordered pair. That is some x, y value, but for a circle, the center is represented by different letters, and it is H, K. And those are alphabetical, just like x, y is. So it's H, K, H comes first, then K, right? Then this is some point on the circle. How many points are on the circle? An infinite amount, right? So all these points on the circle, this is some random point that would just be some x, y value. Okay? So those are all the things that we know about that. We are going to use the distance formula to help us come up with an equation. So remember, distance formula looks like this. Distance with a big old square root. We could all at least get that much, right? And then the reason I said make sure when we do distance formula that you understand that it comes from the Pythagorean theorem because it helps you build it. Now I could just write it down because I know what it is. Some of you may, but most of you probably don't just remember it off the top of your head. But if you understand the concept, you can rebuild it for yourself. It comes from the Pythagorean theorem, so it is something squared plus something squared, right? And then you also know that you never mix x and y. It's never going to be like x plus y type of thing. So this is x, and this is y and y. And since there's plus in between them, minus goes in there, right? And then this is x2 minus x1, y2 minus y1. But do you see how I built it instead of just trying to memorize what was there? You think about what you know about it and come up with it that way. All right? So that's the distance formula that we got originally from Pythagorean theorem. Now we're going to take what we have here, and we are going to substitute in our circle information into the distance formula. So the distance between these 2 points is represented by the radius. It's equal to big old long square root, something squared plus something squared. So it is x2 minus x1, so it's going to be like x minus h, and then y2 minus y1, so y minus k. Okay, so I just replaced what I originally had in my distance formula with the stuff that I have for a circle. Everybody good so far? All right. Now, I need to do a little bit more, but I don't have to just go and try and do all the math I could possibly do. I'd like to get rid of my square root, though. How do I undo a square root? I square it, okay? So I can square both sides. So I'm going to square both sides. So on the left, I end up with r squared. What happens on the right? Good, I just got the stuff underneath it, right? Because what's the square root of a monkey squared? A monkey. So all this stuff in here, that's my monkey, right? The square root of a monkey squared is just the monkey, so it's everything that's underneath there. I get x minus h squared plus y minus k squared. Now, I could actually square these, but I'm not going to and I don't want to. Okay, just because I can doesn't mean I am. That's basically your circle equation, but it's flipped around, so we'll just rewrite it once when we write the equation of a circle. Remember, this is like a skeleton for something for us to substitute things in, just like y equals mx plus b. When you're done and you've written the equation of a line, you've replaced the m and the b with actual numbers that go with the line, right? So when we rewrite this, we're going to replace r, h, and k with information based on a specific circle, and x and y stay in there because it's an equation. Okay, so here, equation of a circle, your standard form, equation of a circle. The equation of a circle with the center, what letters do we use? HK, and radius r is, now this comes from the distance formula, which comes from Pythagorean theorem. It is something squared plus something squared equals something squared. When you write down the equation of a circle, there is absolutely no excuse for you to forget that there's squareds on there, okay? So then this is just x minus h, y minus k, and r. There is your equation of a circle. Okay, we good? Relate it in your mind to Pythagorean theorem so you get the squareds and the pluses and the minuses and everything in the right place. Okay, everybody good? All right, so let's go see how we're going to use this thing. So it says write the equation of each circle. So I'm going to start by on every single question you write down the equation of the circle, you will know it by the time you're done with your homework. It's not an, oh my God, I have to go memorize it type of thing. So it's x minus h squared plus y minus k squared equals r squared. Now, in order to write the equation of the circle, and again, I'm writing the equation. I'm not solving for x or doing anything else. My end result should be an equation. I have to have the center and the radius. Did they give me the center? Yes. What do I label that as? What letters do I use? H, K. Good. And then the radius, so that is R. So then I substitute in everything I know. This becomes x minus 4. Remember, first step, zero work. You just substitute it in. Squared plus y minus a negative 2 squared equals 3 squared. Everybody with me? No. So then I need to go through and clean it up. But remember, cleaning it up does not mean go forth and do all the math you could possibly do. Because I could square this, but I'm not going to, and I don't want to. If I did square it, does it become x squared plus 16? No, it does not. So you need to know it is not that. And I don't really care what it is because we don't want to actually do it, but you need to know if you did, it's not x squared plus 16. Just reminding you of that again. So this first term is fine just like it is. X minus 4 squared plus, what's y minus a negative 2? Y plus 2 squared, and then what's 3 squared? 9. This is the equation of a circle that has a center of 4, negative 2, and radius 3. Okay, everybody good? Okay, so I'm going to give you a minute. I want you to do the next one. That is the equation of the circle, yes. Okay, so that's what I get after I substitute everything in. Do we all at least agree up to this point? Yes. What is x minus 0? X. So this really is just x squared plus what's y minus a negative 3? Y plus 3 squared, and 8 squared is 64. And this is your equation of a circle. That way, if you made a t-chart, you could pick some x values and substitute them in and get you some y values, and you could go forth and graph it. That's not how we're going to graph it, but that's how I want to make sure you understand it's just an equation that you're going to be able to go and graph. Okay, we good? Any questions? Alrighty. So this next one says we are going to write the equation of circle B that passes through negative 2, 6, and has the center of negative 6, 3. All right, so I'm going to write my equation. We've got x minus h squared plus y minus k squared equals r squared. And did they give me the center? Yes. And so this is my center here, so this is hk. Did they give me the radius? No. But they gave me this negative 2, 6. So what is that? xy, because that's some point on the circle, right? So I don't have the radius, which is something that I need to be able to write the equation, but do I have enough information to find it? Yes, I can substitute in everything I know, and then the radius is going to be my only unknown. So I'm going to substitute in everything I know. I have x minus h, so that is negative 2 minus a negative 6 squared plus 6 minus 3 squared equals r squared. So I only have one variable here. So what is negative 2 minus a negative 6? Positive 4. Good. So 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. R squared equals 25. What does r equal? 5. What does r equal? What does r equal?
5 or negative 5.
Good. Plus or minus 5, which is the only one that makes sense here. Does a negative make sense for the length of the radius? No. So when you solve this, you get plus or minus 5. You get two answers every time you take a square root, ever. You cannot lose sight of that fact, okay? Now, in this case, only the 5 makes sense because you wouldn't have a negative radius, right? Okay, just don't forget that you actually get plus or minus. All right, so now I have the radius, which is 5. I need that. I need my center point, right? But do I need this point anymore? No, I needed it. It helped me. I couldn't have done it without it, but I'm going to mark it out because I don't want to accidentally use it again. Okay, so now I have the information that I had at the beginning of the last problem we did. So I've already written this one, so I'm not going to write it again. Just put a little arrow down here. And now I'm going to substitute in everything I have, but not everything because I don't want that in there again. Because when you're done, x and y need to be in there. So this is x minus h, which is a negative 6, squared, plus y minus k, which is 3, squared, equals 5 squared. So this becomes what?
X plus 6.
Good. X plus 6 squared plus minus 3 squared equals 25. And that is the equation of your circle. Just like the equation of a line would have to have an x and a y in it. Or maybe not both if it's vertical or horizontal, but any other line would. Okay, we all good? Any questions? No? Awesome. All right, so I'm going to give you some time to work on the next one. Okay, if you're watching the video, you need to pause it and do it. Okay, so that's what I got. When you get done, see if you agree with me. Don't just copy down what I have, but make sure that you've finished yours and then let me know if you have any questions. Okay, we're good? Yes? Okay, good deal. Now, in the end, here's one thing I want you to see here, that I get r squared equals 16 right here, right? And then I take the square root of it, and then I substitute it back in, and then I re-square it. Your equation actually has r squared in it, right? So when you get to here, you can just take that and substitute it straight in there. I always get that question, that's why I mention it. But I don't know that that's always the best, because then what I see some people do is substitute it in and then square that number. Because if I give you this stuff like it was on the front, you have to square it. If you do it this way, you can just substitute that right in. But some people try that because they think they're taking a shortcut, but then they get confused and do weird, wrong things. You know whether or not you should do it the safe way. And the safe way is to go ahead and find r and then substitute it back in. But it's not wrong if you do it that way, unless you do it wrong, of course. But, okay, we're good? Awesome. All right, let's look at the next one. Next one says we're going to use the equation to find the center and the radius of the circle with this equation. So I'm going to write the equation of the circle again. X minus h squared plus y minus k squared equals r squared. And then I'm going to basically work backwards from what I had been doing. And this is the cleaned up version. I need to unclean it up. And so it's still going to be something squared plus something squared. Give myself an affirm. Something squared equals something squared, right? And so this is x minus y minus. So I got to figure out what would go in those blanks, right? So if I'm using this equation to get here, this would be x minus what? Negative 3, y minus 5, and then what goes here? 2. Okay? Because then for my center, my radius, my answers are right there. This is h, this is k, so that's negative 3, 5. This is my radius, this is 2. Okay? So it is the opposite of what you see in the equation. You got to be careful with that. Okay, we good? Questions? All right, so you do the next one. If you're watching the video, you need to pause this and work this question. All right, so what goes in here? Negative 7. What goes here? 0. Good. What goes here?
48. Square root of 4 times the square root of 3.
Thank you. Yes, and in parentheses, Jacob. Just made me feel so good. It's the first time all day that I haven't just gotten the square root of 48. Because am I supposed to take the square root of this? Yeah, because r squared equals 48, right? So r is the square root of 48. But have you ever been allowed to leave it like that? No. So you got to simplify it, right? And when you do that, you get 4 square root of 3. And on top of that, I can't just write it like that, right? If I write it like this, all I'm saying to do is square the square root of 3, and that's a big fat no-no. So just like Jacob said, it is 4 square root of 3, and it has to be in parentheses there. Okay, very good. Questions about that? So this is my h, this is my k, this is my radius. So this is negative 7, 0, and the radius is 4 square root of 3. There is hope for the future. Okay, we all good? Questions? All right, so let's go and graph these. Oh, yay. Okay. You sound so excited. All right, So before we graph them, we have to basically do what we just did. You have to write down what the center and the radius is, because that's what we're going to use to graph these. We're not making little t-charts or anything. So looking at this equation, what's the center? 0, 0. Good. What's the radius? 5. Okay. So when we graph this, you start by plotting the center point. So this is the center, and I label it C for center, unless it tells me the name of the circle or something. But there's the center, because this isn't actually a point on the circle, it's a point in the circle, but we need that point in order to plot the other ones. Because I don't want to make a t-chart, and I don't know that I'd pick the right numbers and everything. I can actually find 4 points that I can graph, right? Yeah, 5 from the center, right? So I'm from the center, I can count to the right 5, bam, there's a point. I go back to the center. Do I get to count diagonally? No, but I can count vertically up 5, there's another point. I go back to the center, go to the left 5. Go back to the center, go down 5. Okay, so there's 5 points that I expect to be plotted. The center point and then the 4 up, right, up, down, left, right. Okay, then you have to do your best to get a circle in there. My suggestion would be to do a dotted line. If I just try and draw a circle in here, I ain't even going to hit those points. Okay, so but you do not connect the dots and get a square either. So I'm going to do dotted lines, and that I can already tell you that that was not good. Bad start there. Dotted to get my circle, or to the best of my abilities. This is not an art class, but it needs to look like you made an attempt to make it look like a circle. Okay? Don't stress out over making it perfect. It may look like a squished egg or a football. Mine's a little lopsided, but it's really good enough. Okay? No, not as long as, no, a solid line's fine. And the smaller it is, like I might be able to do it on the paper better as a solid line. I know I couldn't do it up here because it's too big. I just totally missed what I needed to do. Okay, questions? Awesome. Then you graph the next one. What's the center?
-1, 2.
Good. -1, +2. What's the radius? 3. Awesome. All right, get that graphed. Turn that off, please. All right, so does your circle look like mine? Or maybe better? Okay. Should be in the position and same size and everything at least. Okay, so now we are going to graph a line with one of our circles. I want you to graph the line y = x on this grid right here. Okay, so graph y = x on that grid. Some of y'all are graphing away. Some of you look very, very confused. So here's my tough love for the day. If you have no clue how to graph that line, pre-AP Algebra 2 is probably not for you. Because if you're going to get stumped on something like that, you're going to be left in the dust. All right? That is the easiest, one of the easiest lines you could possibly graph. It even has a special name. It's called the what function? Starts with a P. No. Nice try, but it's not the particular function, no. The y = x squared would be what that function for a parabola. Starts with a P. Everybody biologically has 2 of them. Parents. Okay.
Oh
All right.
my god, I remember it now.
Thank you very much.
We
Okay.
did this at the beginning of the year. It was on like our summer project.
Yeah, you did this in, let's say, oh yeah, Algebra 1? Yeah. It's called a parent function. What is the slope of this line? 1. What is the y-intercept? 0. So if you have to, you shouldn't even have to think that much. If you have to think that much, you will never, ever, ever see it written like this, but this is basically what's happening, then you should be able to get that thing graphed. Get it graphed. It makes me want to cry. Okay? Oh, that's okay, but just, it's okay if it's over there too. Just get it on this one. That's fine. I'm going to make mine solid just because I can use this cheating thing, but if yours is dotted, that's fine. There is one, I just couldn't get it exactly where I wanted it. Like I can make a circle, but I don't know how to make a circle exactly where I want it. I mean, I could do it and then move it. It's just not worth it. It's fine. Biggened it. If I biggened it. All right. So here's my line with my circle, right? What kind of line is this related to circles? What's our vocabulary with this circle? A diameter is not a line. It's a what? Secant. It is a secant line. A diameter and a chord are segments. This is a secant line because it intersects the circle at 2 points. Does a chord live in the secant line? Yes. Does the diameter live in this secant line? Yes, it does, but the line itself is a secant. Does every secant line contain the diameter? No, because I could have a line right here and it wouldn't contain the diameter. It can contain a chord, but this one just happens to go through the center of the circle. Okay, so it intersects the circle at 2 points. Now, what if I wanted to know exactly what those ordered pairs were? Do I get to just pull it off my graph? No, heck no, especially not these because they ain't even necessarily in the right place, right? But it's about in the right place, yes. Well, isn't the radius the same all the way around the circle? Yeah, so from here to here is the same as from here to here. So me knowing the radius isn't going to tell me where that point is. Okay. So think about, you've done graphs that intersected before, and you found where they intersected. How did you do that? When did you do that? You did it in Algebra 1. You graphed, but y'all just did with lines, right? So you graphed 2 lines and they intersected. You wanted to figure out where they intersected. What's that called? Something of something. It is the point of intersection. No. It's the point of intersection, but how did you find it? We did it this year too, we just didn't do it on the graph. It's something of something. It's the 2 things. What is lines of equations? You'd have equations of lines, but you have 2 of them. It's the 2 equations with 2 variables. System of equations. Yeah. It was in your brain. Okay. So, look at what you have here. We have this equation, right? And we have this equation. Do we have 2 equations? Yes. Do we have 2 variables? Yes, it's a system of equations. Now, all that you did was linear, and all we've done so far is linear ones. You had 2 lines, right? But you could have 2 lines, you could have 2 parabolas, you could have a parabola and a circle, you could have a line and a parabola. It doesn't matter. It's still a system because you have 2 equations and 2 variables, okay? We are not doing it graphically, okay? We are not going to graph it and pull our points off because we can't graph a perfect circle, and even if you could, that's not the only way you need to be able to do things. But that's what it's going to ask us to do down here. Okay, it says find the points of intersection, and that S is in parentheses. So let's think about this. Here I have 2 points of intersection. Well, clearly it doesn't have to be plural. Could I just have 1 point of intersection? Then what would that kind of line would that be? If the line intersected at 1 point. Tangent, very good. So it'd be a tangent line. Could I have no points of intersection at all? Sure, the line could be totally unrelated to the circle, right? So you could have it intersect at 2 points and its secant, 1 point and its tangent, or not intersect at all and just not have an point of intersection. Okay, does that make sense? Yeah, they just not intersect, yep. All right, so this says find the point or points of intersection between each circle and line with the equations given. Then state if the line is tangent or secant. So how are we going to know if it's tangent or secant?
By the way
Yeah, 1 point or 2 points, right? Depends on how many answers we get. So this right here, 2 equations, 2 variables, what's it called? System of equations. All right. So if you remember when we did systems of equations, we didn't do it graphically, but we did it with substitution and elimination. And I told you at that point, because there were quite a few of you that really liked elimination better than substitution, and that's fine, but that cannot be the only way you know how to do it, because elimination is not going to get you anywhere here, right? But, well, can I use substitution? Yeah, and this is already solved for a variable, so that's nice. I can just take this and substitute it in right there for y. So this is going to give me x squared plus 1/2 x squared equals 5. Are those parentheses important? Yes. Okay. So this becomes x squared plus what? What's 1/2 squared? It is 1/2 times 1/2, which is 1/4. Good golly. X squared plus 5. No, not plus 5. I'm sorry. Equals 5. Equals 5. You don't need the parentheses anymore because you've already used them. Okay. All right. So at this point, you could choose to just deal with the fractions as fractions, or you could get rid of them. What would you rather do? Get rid of them. Okay. And that's fine if you get rid of them correctly. So my concern with getting rid of them is that you always do it correctly. And there are definitely times where that's how you need to do it. All right. If I'm going to do that, what would I multiply this by to make the fraction go away? 4. Okay. So when you do that, you can't just think in your head, okay, I'm going to multiply both sides by 4, because what some of you would do would be multiply this one by 4 and this one by 4, and that's it. When you do it, I'm going to make you right now write an extra step. You don't have to do it every time, but I want to make sure that everybody understands that when you clear the fraction, you have to multiply every single term. So that's going to become 4 times x squared plus 4 times 1/4 x squared equals 4 times 5. Now, I wouldn't make you write that step every single time you ever did one, but I want to make sure you understand what I mean by every single term. At the very least, most of you, it probably wouldn't hurt if you just put like 4 times 4, you know, at least above each one of them so you don't forget. Because I don't think it's really a matter of misunderstanding. I think it's just a matter of you being sloppy with your work sometimes. Absolutely, yes. You can put it in parentheses as long as some people would do that and still wouldn't distribute. But yes, whatever works for you so that you can make sure you do the whole thing, that's absolutely fine. All right, so what this gives me then is 4x squared plus what? X squared equals 20. Okay, so 4x squared plus x squared is 5x squared equals 20. So can I take the square root of both sides? No. Okay? You have to divide by 5. So I get x squared equals 4. So what does x equal? Plus or minus 2. Jacob is on fire today. It is plus or minus 2. If you just do 2, you are wrong. Okay? When you take the square root, you get 2 answers. And this isn't representing the radius, so I need both of them here, right? Now remember, what I'm looking for is the points at points at which the circle and the line intersect. I have 2 x values. What do I have to do now? Find the y values. Okay, I have to substitute it back in. When I do that, does it matter which one I substitute it back into? No. Which one would you choose? The y equals 1/2 x. Heck yeah, why would you choose the first one when you could choose the second one, right? So down here, when x equals 2, then y equals 1/2 times 2, which is what? 1. And then when x equals negative 2, y equals 1/2 times negative 2, which is negative 1. All right, so what do you think my answers need to look like in the end? No. Well, I'm looking for points, right? How do I write points? Ordered pairs, right? So this would be 2, 1, and this would be negative 2, negative 1. So would this line be secant, tangent, or neither? Secant. I have 2 points of intersection, so this is a secant line. Okay. Does that make sense to you? We good? All right. Any questions? All right. So you are going to work on the next one. And if you're watching the video, you need to pause it and work on the next one. All right. So I'm going to take this and substitute it in here for y. So x squared plus negative x plus 2 squared equals 2. So when I square this, do I get x squared plus 4? No. I'm going to get x squared plus x squared minus 4x, sorry. Minus 4x plus 4 equals 2. Okay, everybody good with that so far? If you don't know how to multiply this out, you better go get that figured out. All right, so this gives me 2x squared minus 4x plus 4 equals 2. Now, what kind of equation does this look like? Quadratic. So what do I need to do? Set it equal to 0. So I get 2x squared minus 4x plus 2 equals 0, right? Then I'm going to have to factor it. When you go to factor it, what is the first thing you always look for? GCF. Okay, now listen carefully to my words. You factor out the GCF. You do not divide it out. If you divide it out, you are wrong. He does not disappear. What is the GCF? What is it? 2. So 2 times x squared minus 2x plus 1 equals 0. You have to know how to factor. You have to know how to multiply binomials and trinomials. You can't keep trying to ignore it like some of you do. Like some of you have tried to do fractions since 3rd grade. Okay, and I'm just going to show you this because I happen to have it up because that's what I was doing with my pre-cal classes. But I want you to look at, where is it? It must be on the front. This, because eventually you're going to be factoring things like this. And if you can't get the basic factoring done that you learned in Algebra 1, and you are still trying to work on that when you are then in Algebra 2, you're not going to get the skills you need to finally factor something like this. And I don't know why y'all are putting up because I'm not done. And then you're also going to have to multiply things like this. If you can't multiply basic stuff like we just looked at, and look at these fractions. If you don't know your basic fraction rules, none of this is as difficult as it looks, but the calculator isn't going to help you at all with that. Not at all. Okay, so if you keep trying to use a calculator every time you got to do a fraction, you are hurting yourself because you can't do any of this stuff. All right, okay, so back over here. I go to factor this. It's got to look like this, right? So I know since a is 1, this is x, this is x. I need two numbers that multiply to give me 1. What are they? 1 and 1. Okay, I don't know why you're gluing because I'm not done. And then they have to add to give me a negative 2, right? So what are the signs here? Negative, negative. If this is a positive number here, the signs have to be the same. Okay? So then I take each factor and I set it equal to 0. 2 doesn't count as a factor, right? But this does. And there's the same one twice, so it's a double root. So I only have to do it once. So x equals 1. It's a tangent because you only get 1, right? You substitute it back in. Let's do that real quick. What is it? You get y equals negative 1 plus 2. So y equals 1. So you get one ordered pair, which is at 1, 1. And that is a tangent. And there you go. Have a good day.